The behavior of TCP, that is central to the operation of various application layer protocols, is governed by the fact that how is it implemented on the server side. Therefore, it becomes important to look at various implementation options. In this module, we'll look at the widely acclaimed form of implementation called the threaded TCP server implementation. We shall look at the basic operation of a threaded server, what are the options that we have in threading, and what is the support given to us in Omnet++ for providing threading support. Let's look at a threaded architecture first. Here you see that the clients coming from the left hand side as host with IP address A and host with IP address C connect with server with IP address B. Server is running the server application. If the server application is non-threaded, as we shall briefly see, it will manage a single queue and it will manage centrally the disbursement of CPU cycles and transmission schedules for all the incoming requests. So any misbehavior on part of either the clients or the transmission delays or the server-side implementation could cause total chaos, and all the clients would suffer because of the misbehavior of a single client or anything going wrong with the server. So the threaded server provides us a workaround. Threaded server implements the server side as threads. Threads can be considered as the instances of a master class or the master thread that creates a new object or a new thread on the arrival of a request from the client side. So if we summarize that the single threaded web server runs only one program, we can also call it the main thread. The requests arrive on the main thread itself. The connection is accepted. The request is extracted and processed, and response is generated in a first come first serve basis. So if by coincidence a misbehaving client sends its requests which happen to be treated first, and the legitimate and fair clients follow that client, as a consequence they will greatly suffer. So the multi-thread web server provides us an alternative that for every new coming request, a new worker thread is instantiated. So if anything goes wrong with that thread, the other threads literally remain unaffected. The support for TCP in the INET framework is very broad. It covers the basic RFC 793 and goes up to the selective acknowledgement implementation for TCP, which is the non-default implementation of TCP congestion management and buffer overflow. The features which are implemented in TCP, you can look at the NED files there, are the states and state transitions as given in RFC 793, connection setting up and tearing down. All these can be considered as singular service, and if these are implemented as a class on the server side, and for every new coming request, its object is instantiated, what we are doing is we are implementing a threaded server. The features which are greatly affected with the thread design is the receiver buffer to cache the data which is being sent out to the client end, and the data which has been sent or the data which has not been forwarded, because as the server sends out data, it also expects the acknowledgement and only clears the data in its buffers when the acknowledgements have successfully been received.